In this program, we're going to look at another example that involves putting a link inside of a structure. So we'll do the same example or use the same structure we did in the previous video, where we have the student record with this data and we have the link. Before I go any further, I should actually introduce some new terminology. When we have a combination of, within our structure, of members that are ordinary data, as highlighted here, plus a link, then we usually call that a node, N-O-D-E. So that's the term I'll be using as we go forward. And as we make a linked list, then you can think of a linked list as just being a chain of nodes, one attached to the other. Let's scroll down, and you'll notice that we, in the previous video, we used a student record for Susan and for Roger, and part of our example, we ended up connecting Roger's link to Susan. So what we really did in that example was to make a two-node linked list. Now we're going to make that more formal. So let's go down to the area where the comments show up, and let's add the code necessary in order to make a linked list. To make a linked list, we need to have some additional variables. So let's declare those variables. I suppose we can declare them right here, and we will use the terminology that's typically used with a linked list. So we will have some student records, and these will be pointers, and we will call one of them root. The next one is a current node, current underscore node, and the last one will be a new node. So we're using that node terminology here already. All right, so given those three variables, let's use them to make a generic linked list. So we aren't actually naming these pointers like we did before with Roger and with Susan. We're using generic indicators here or names for these three pointers, and we need all three of them to make a linked list. The first step says to create a root node. Well, let me fix that. That should be a T. So what I want to do is I'm actually going to use the current node pointer to do that. So I'm going to make a node. So current node is just equal to a new student record. So we will allocate the space. The new operation just is a request to the operating system to allocate space for the student record, and it returns the address and it saves it in the current node. Once we've created the node, then we can go ahead and put some data into that node. Now the data is going to be student record type information, but it isn't going to have a specific name as part of the pointer itself. It's just going to be called current node. So let's call enter data. So we have enter data, and in parentheses we will use the asterisk and current node and semicolon. So when we call the function, then it will prompt us to type in information for this particular student. And you will remember that the enter data function does not have anything within itself to set the link. So we will come back, and in step number 3, we will set the link of the current node to null. So we can just do current node, little arrow notation, link equals null, semicolon. Now, number 4 says we have to save the entry point, so we are going to set this root node to be equal to the current node. So the code for that is just simply root equals current node, semicolon. We're going to stop right here, and we're going to run the program and see what we have so far. But after we have made this initial node, looking ahead a little bit, we're going to enter a loop, and we will make some more nodes, and we will connect those up. But for right now, let's just go ahead and run the program and see what we have. So I'm going to build it. Okay, so I executed the program, and I did go ahead and type in the data for Roger and for Susan because that was already part of our program from the last time. So we still had this information up here, these lines of code, so I had to go ahead and get past that. Okay, so now we're sitting at the system pause, and then we're ready to go down and go through making the first node of the linked list. So when I hit any key to continue, then we'll be calling the enter data function to enter the data for the new student. So that's this line right here. Alrighty, well, let's type in some data for this student. Okay, I'll make up something. Date of birth, let's say 3/15/2001, 19, math, and then it says press any key to continue. All right, so that means that we have progressed up to this point. Nothing is in the code, and now we're at the end of the program down here. So thus far, what we have done is we have just declared these pointers to student record. We have allocated space with new and set that to the current node. We call the enter data function to type in data, and we connected the link, or we set the link to null, and we set the root pointer to the current node. Now that we've done this, let's compile the program and run it, and we'll type in the information for the first node, and we'll use Roger's information for that. So here we are. We're running the program. We've called enter data, enter the first and last name. Let's put Roger in. Let's put in the birth date. And let's put in the major. And then it says press any key to continue. All right, so at this point, our program has done the following. We've created a new node. We've called the enter data function, and we've just typed in the information for that. And we have set the link to null, and we've also set the root to the current node. So that's all we have so far. Let's look at a diagram of what we just did. The current node equals new student record created a new node, and the current node points to that node. And here you can see that we created the space, but we didn't initialize this to anything. Then we had the enter data to the current node. We called the function to do that. And the function prompted us to type in the name and the date of birth, the age, the major, but we didn't do anything for null. But when we came back to the main program, we set the link part of the field to be null. So at this point, we had the current node pointing to this information. And finally, we made a copy, essentially, of the current node for root. So now root points to the node containing Roger's data, and the current node points to the node containing Roger's data. Now let's go back to the code and go down to the loop, and let's add some additional nodes to our list. So you can see that we have the while loop, and the while loop has several steps, and we have a small number here. So while the count's less than or equal to 2, so count is 0, so this will give us 3 additional nodes. Look at the comments here. Make a new node. So we're going to repeat the steps that we did above, but we have a little bit different terminology because we're not going to use the root node here anymore. So to make a new node, let's call it new node, and that's equal to new student record. So that gives us the space. Now we will call our enter data function to fill the node with some data. Okay, so enter data, and we'll dereference new node. So the function will prompt us to type in some data for this student. When we come back, we'll set the link to null, because the enter data function, as I've mentioned too many times now already, that does not set the link part of it. So for this new node, we want to make sure that the link is set to null, otherwise it is not defined. So we have new node, little arrow, link is equal to null. Then notice we want to connect the previous node to this one. Well, this is our first pass through the loop. So the previous node was the one that we made up here. And the node that we made up here, the current node, that pointer points to that first record, that first node. So that is the previous node. So if we want to take that previous node and we want to connect it to this one that we just made, then we want to set the link part of the current node, which was previously null. We want to set it so that now it points to this new node that we just created. So we'll do current node, the link part of it. We're going to reset it from null to new node. So now the node that we created up here is now connected to this new node that we made down here. Now let's go ahead and let's make another step, and this is the only other step we need to do to make this linked list. We have set the current node link to point to the new node. We have root pointing to the current node. So we can now relocate the current node so that it points to this new node. So let's do that. Okay, so let's set current node equal to our new node. That means that we have current node points to the node that we just made up here, and new node also points to that one. The only thing pointing to the beginning of the list now is root, because we just changed the current node. Now, let's go ahead and run this program and see what we get. As we pick up here, we will need to enter in the information for the first node again. So this is the node that was created up above the while loop, so it'll be Roger's data. So his date of birth, I forget what I typed earlier, we'll just put that in. I do know he was a CS major. Now, we are inside the loop. We have made a new node. See, there's the while loop. We've just made the new node, and now we've called enter data again with the new node link, and now we want to put in data for this second node, this new node. So let's put in Susan's data here. And we'll put in her information. Math major, and we'll type enter. Now, we'll stop right here for the time being because we have just gone through this loop another time. So count is 1, and we haven't finished going through the loop yet. So let's stop right now, and let's just look at a diagram of the linked list up to this point. Step number 5, where we create the new node. So a new node is equal to a new student record. And here's a little square, shows you the elements of that, the members of that structure plus the link and new nodes pointing to it. So here we create the new node. We will call enter data at this point, and we will type in the data for Susan. So you see her information is here. And then finally, step number 7 says that we're going to set the link to null. So the new node is pointing to Susan's information, and here at the bottom left you can see that information. And moving over now to the upper right side, we want to link these two nodes together. So that's what steps number 8 and 9 do. Previously, note that the link part of Susan's data and of Roger's data, the previous ones, were both null. So we want to reset that. If you look at Roger's information here, then you will see that at the very bottom, we have changed his link to new node. So now that points over to Susan's information. Then, once we're finished with that, the nodes have been connected. So Roger's link now links to Susan. We no longer really need the current node to point to Roger. We have the root node pointing to Roger, so we can move our current node pointer over, that's step 9, so that the current node pointer now points to Susan. So now the new node pointer points to Susan as well as the current node pointer. Now let's return to the code and look at the loop. We have the while loop. And the while loop repeats for 3 times. So we're going to add 3 additional loops. We don't have to add any additional code in order to complete the linked list. We had just finished making a new node for Susan's data. So we filled in that information. We connected the node for Roger to that for Susan. If we want to make an additional node and connect it, we just repeat steps 5 through 9. We make yet another new node. We fill it with a third student's data. We set the link part of that third node to null. And we connect the previous node. Now remember, current node points to the previous one. So current node link is equal to this new node that we just created up here. So that links the previous node to our new node. Once that linking is done, we can move the current node pointer up to the new node. So that's what step 9 does. And finally, just count plus plus counts the additional nodes that we are adding to our linked list. Now let's run this program one last time, and let's fill up the linked list, and we will end up with a linked list that has 4 nodes. So we will need to start at the beginning, since I just started the program over, and we will need to fill in all of the information. So let's start with Roger. And his birth date is sometime in February. CS major. Okay, now the next one, so we made the first node. Now we're going to enter the loop, and we'll type in Susan's information. She's student number 2 and node number 2 in the list. Okay, she was a math major. And now we're continuing to go through the loop another time. So this is entering the data for the third student. So let's make that Nancy Clark. See, August the 5th, making up some information here. And her age and the major, physics. How about that? Going through the loop another time for yet another student. So let's type in the data for this 4th student. Okay, so George Messina. These are not real people. I'm just making up names. 11/8 of 95. Okay, age, major, okay, CS. And that means we have filled up the list. Okay, so we have reached the end of the program. It says press any key to continue. All right. Well, we aren't printing out anything from this. We just built the list, and we typed in all the data for these several nodes. So now let's go back and let's look at a diagram of this linked list that we just created. This chart shows what we just did. So here you can see that the root node is pointing to Roger, and the second node in our list was Susan. Then we went through our loop past number 2 at the upper right. You can see we're past number 2. We create a new node. When we do step number 5, new node wipes out the previous pointer that we had that pointed to Susan. Now, new node points to another node, which has to be filled with data. We call enter data number 6, and we type in data for another student called Nancy. We set the link to null. So we have moved the new node pointer away from Susan. Now that points to Nancy. The final thing that we need to do is now to move the current node over. So in step number 8, we set the current node link to new node. That connected the Susan's node to Nancy's node. Then the current node no longer needs to point to Susan. It can now move over and point to Nancy. So in step number 9, we set current node equal to new node. And as we go forward, we just repeat this same process by changing the links to add additional nodes to the list. This slide shows what would have happened if we had gone through the loop 4 times. And actually, we only went through the loop 3 times the way I did it, so we didn't have this last node. But you can see that here is a representation of our linked list, and it shows the nodes, Roger all the way through Karen. And at the very end, what we have is in the last link of the last node, it remains null. It's important for that to be null because this is a indicator that we can use to tell us when we get to the end of the list. To complete this program, let's go back to the code and let's print out the linked list that we just made. So this at the bottom of the code says print out the data, start at the root node. Alrighty, well, we don't need to use these other pointers anymore, except we have to keep the root node because it points to the first node. So let's use our current node and let's set it to the root to begin with. So that points to the beginning of the list. Now, let's use our print data function. So we'll call print data, and we will send it a dereferenced current node and semicolon. Then we will just, that's not a semicolon, that's a semicolon. Now let's go back and let's just have a loop that will terminate when we get to the link that is null. Okay, so while current node, little arrow, link, as long as it is not equal to null, then we want to stay in the loop. Let's put our parens around that. Then we have printed out the data from the first node. So let's move on to the next one and let's print out that information. Alrighty, so let's just do a cout here. I probably should do that higher up as well before we printed out the data for the student, but that's okay. Double quote, student, I'll make that uppercase, student record. And let's put a couple of end lines. This will separate the nodes. All right, that's good. Let's do the same thing up here. Let's copy and let's paste so that we get that for the first student as well. All right, so now we're inside the loop. We have printed out the data for the first node, the first student. So now we need to move to the second node in the list. How do you move to the second node in the list? Well, we know that the link points to the next student, the next record, the next node. So let's set current node equal to the current node dot link, or the little arrow notation. Okay, be sure you know what's going on here. Okay, we take the link that's in the current node, which in this case, the first time through the loop, that's going to be our first node. We take that link and we make that our current node link. So that now means the current node points to the next node in the list. Then all we need to do is to print out the data for that student, and we are done. That's the end of it. This is called traversing the linked list. So we keep going through the list until we find a link that's null. I'm going to compile the program and I'm going to run it, and I'm just going to type in the data for the students, and then we'll come back to this point where we're printing out the information. I'm at the point where I've started the program and I have typed in all the information to fill in all the nodes for the various students. So I am just about to type in or hit enter for the last one, the last student in our while loop up here. So then we're going to drop down and we're going to print out all this information by calling print data. So I will just hit enter. And we are now in the loop at the bottom, so we print out student records. So you can see that the program progresses through the linked list. We have Roger, and then Susan and Nancy, and finally George at the bottom. So this loop at the very bottom over here prints out the data, and it is traversing the list. It stops when it finds a link that's null. So that then will complete this particular program, but there is one more chart that I want to show you. This final chart is just a summary which shows you all the steps that are involved in creating a linked list. So you have the flow diagram, and then you have the lines of code to the right showing you what's going on. So we just create the first node, you load the node with the data, you set the link to null, then you set the root node to the first node. That establishes the first node in the linked list. And then inside the loop, you see all the steps that are required to create the remainder of the linked list. That will do it for this recording and this video. So hopefully that will give you a really good idea of how we can use an embedded pointer within a structure to create a linked list. And that's all for now.